here we go. Second derivative test. Let x equal c be a critical number. So we've already found the critical number. Now we're just trying to classify it. Let's suppose that we're just dealing with a continuous function f here. And f prime of c is equal to 0. And f double prime is continuous near this critical number. Just to kind of avoid some special cases and things. So we're making just a few extra requirements here. So let x equal c be a critical number, and the important kind of additional point here is that the derivative is 0. So it's a special type of critical number. It's where the graph kind of flattens out. All right. Well, there's kind of 3 options here for the second derivative. So the way the second derivative test works is we first identify our critical numbers, then we calculate the second derivative, and then we plug our critical number into the second derivative. And if the second derivative is negative, then we have a local max. And if the second derivative is positive, then we have a local min. And if the second derivative is 0, then this test is inconclusive, and we have to use the first derivative test. So that's kind of one of the little things about this test. We can't always use it like we can the first derivative test. There's a few extra conditions here, and sometimes it's inconclusive. So if you calculate the second derivative and you get 0 at your critical number, then you have to use the first derivative test. So let's just make a note of that. So if you get inconclusive, use the first derivative test instead. So sometimes that happens. The first derivative test always gives you an answer. Second derivative test sometimes is quicker because we don't have to do a whole sign chart. We only have to calculate the second derivative and just plug one number into it. We don't have to do a whole sign chart. The downside is sometimes it's inconclusive. So if it's inconclusive, no way around it, then you have to go use the first derivative test. All right, so how do we remember what this test says? Well, if you have your critical number and you know it's the derivative is 0 there, so that's kind of this extra little condition that we just want to keep in mind. It's a critical number, but it's the critical number where the derivative is 0. Well, let's suppose that let's suppose we're going along. We don't know what our graph looks like, but we know that f prime of c is equal to 0. And we've calculated, so it's a critical number, and we've gone through and we've calculated our second derivative, and we found that the second derivative at c was negative. Well, what do we know about second derivatives? They kind of tell us about the shape of our graph. So if the second derivative is negative, right here, what is the shape? It's concave down. So draw in to kind of help remember or remind you what the second derivative test says. If your second derivative is negative, draw in that concave down shape. And make it nice and rounded because the first derivative is 0. And we've drawn in our concave down shape. And what we've drawn, if this is going to be our curve, right around x equals c, what we've drawn looks like a local max. And that's exactly what this test says. We have a local max. Now, if we're going along, playing our games, trying to classify critical numbers, we find x equals c is a critical number where the derivative is 0 there. So it's a nice kind of smoother transition in our graph. The derivative is 0. It flattens out. And we're going along and we calculate f double prime. And we find f double prime is positive. Well, we know the second derivative kind of tells us about the shape of our graph. And so the concavity. So if the second derivative is positive, we know that's concave up. And so let's get a rough little sketch of what our graph looks like right around x equals c. It's going to have a concave up shape. So draw in your concave up shape. And what did you just draw? Well, we just drew in something that looks like it has a low point. And that's precisely what this test tells us. We have a local min. So the second derivative test a lot of times is a little bit quicker. But kind of the downside is extra conditions. So we can really only use this for where the derivative is 0. Why can't we use it if the derivative is undefined? Well, because then we're looking at the second derivative. So if the first derivative is undefined, the second derivative is going to be undefined as well. So this only works for classifying critical numbers where the derivative is 0. So that's kind of one slight thing. The other thing is sometimes this test is inconclusive. So we have to use the first derivative test. But the upside is sometimes this is a little bit quicker. So you have options. All right, so these are our two tests, the first derivative test and the second derivative test, to help us classify our critical numbers as either a max, min, or neither. Next, we're going to try some examples, how this looks like in practice.